Hello, everyone. We will just wait a few more minutes for additional people to join us. Well, I guess we can start already. There will be a recording of the webinar, so for those who couldn't join us today. Okay, so hello, everyone. Welcome to our first public webinar. My name is Lavica. I'm here on behalf of AVS Solutions. And here in AVS Solutions, internal training and knowledge sharing is a key part of our culture. As a software development company, we are always eager to explore new technologies that enhance our skills and improve our work. And we are naturally drawn to innovations in this field. So Angular Signals was no exception to this. When we first encountered Angular Signals, we decided to approach it with some caution, and we chose to take a measured approach and gradually incorporate into our applications. Today, we are excited to share our journey and offer insights into benefits, challenges, and the impact of implementing Angular Signals in the real-world projects. What you will hear today is based on our hands-on experience on what we believe can also be valuable for you as well. Before I hand it over to our main speaker, I would like to encourage you to ask any questions using the Q&A section, and we've set some time aside at the end of the presentation to address them. Now, without any further ado, I'm pleased to introduce Miomir, who will be our main speaker for this webinar today.
Hello, everyone, and welcome to today's webinar. My name is Miomir, and together with my colleague Vladimir, we will guide you through a session on mastering Angular Signals. We really appreciate your time and the opportunity to share our experience with you. We understand that many of you are already familiar with Angular and its core concept, so our focus today will be practical approaches for using signals in more complex application rather than a basic introduction. As I mentioned, I am Miomir, and I have been working with Angular for over 7 years now, primarily focused on building scalable front-end solution. My colleague Vladimir has intensive experience in system design and architecture. Together, we hope to provide you insights that will help you in your projects. Here what we'll cover up today. First, we will quick recap the core concept of Angular Signals to ensure we are all aligned. Then we'll discuss key benefits, best practices, and advanced patterns that are particularly useful in larger applications. We'll dive into live demo where we implement some of those techniques in a real-world scenario. And finally, we'll open the floor for questions and discussions, so feel free to note down any questions during the presentation. First, we'll start with a simple understanding. Let's start with a brief overview. Angular signals provide a way to manage state in your application, which can simplify your code and make it more declarative way. Instead of relying on event emitters and manually managing subscriptions, signals allow you to focus on state transformation and automatically update components when the state is changed. Key difference compared to the traditional methods like observable or input-output, signals provide a more seamless way to handle state changes. Instead of manually subscribing to events or writing boilerplate code for event handlers, signals automatically react to changes, reducing the complexity in your components, basically. Signals are especially useful in applications that require real-time updates. For example, consider a dashboard that constantly updates based on new data. With signals, you can assure that your UI is always in sync with the underlying state without needing to manually trigger updates or manage events. There are some benefits, of course. One of the most significant benefits of signals is the way they improve communication between components. Components can react to state changes without directly depending on each other, which leads to better modularity and less coupling in your code. Signals also simplify state management. Instead of manually handling subscription or event emitters, signals take care of notifying components when state change, reducing the amount of boilerplate code. Also, with signals, components become more reusable because they respond to external state changes rather than directly interacting with each other. This makes the application easier to refactor and maintain, especially as it grows in complexity. There are also best practices for using Angular signals. First of all, naming conventions are critical when working with signals. Descriptive and consistent names helps communicate the purpose of each signal. For instance, a signal is a loading name immediately conveys its role in application. In large application, managing complex data flows sometimes may become a challenge. Where the signals are used effectively, they simplify how to track and transform state. Chaining signals or deriving new signals from existing one can help manage more complicated flows without requiring additional logic in the components. Also, best practices is avoid overcomplicated state management. It is important to keep the use of signals simple and purposeful. For now, let's say you can focus on using signals directly with the components, managing state transformation in a straightforward way. As your application grows, you can explore more advanced methods for structuring state. For more cases, signals can remain for now within the components. Also, there are common patterns with Angular signals. One common pattern you will encounter with signal is publish subscribe, pub sub pattern. In this setup, one part of the application updates a signal, while other parts subscribe to changes in that signal. This allows different components to react to state changes without needing direct communications. Signal chaining is another powerful pattern. You can derive new values from existing signal, making it easier to manage state transformation. For example, you have a signal that tracks user input. You can chain another signal that transforms that input a filtered or proceded results. Signals are also effective cross-component communication. By having multiple components subscribe to the same signal, you can ensure that you stay in sync without requiring direct interaction between them. This promotes better separation of concern, of course. In our upcoming demo, we are going to explore these patterns in practice using signals to manage state and communication in more complex scenario. One of the most important things is to identify and avoid pitfalls. While signals offer a lot of power, it is important to avoiding overusing them. Not every state change needs to be managed by the signal. For simple cases, traditional mechanisms like input and output might still be the more effective and appropriate way for you. Also, signal reduce complexity, then can induce performance overhead if not used carefully. For example, recalculating signals too frequently can impact rendering performance. Techniques like memoizing, this means that every new read of a signal will return its current cached value. Only the first read will trigger any calculation. Signals can help optimize performance by ensuring that signals only updates when dependencies changes. Debugging, of course. Debugging signals can sometimes be very tricky, especially with dealing with reactive state. We are all familiar with the Chrome DevTools. Using tools like that can help track state changes and ensure that your signals are behaving as expected. Another very important part is unit testing. Unit testing is a crucial part of working with signals. Writing tests to verify the signals are correctly responding to state changes can help catch bugs early and ensure your application behaves stable. Of course, in our demo, we'll have some practices on how to avoid common mistakes when working with signals and how to solve them effectively. This was just a brief introduction into signals. Now let's move to the demo. We have built a simple Angular application where signals manage state across multiple components. During the demo, I will show you how to use signal chaining, cross-component communication, and optimization. You can feel free to write questions during the demo. We'll address them as we go, and we'll have additional time for the questions at the end of the demo. Now I will share my screen with another thing. Sorry. In this, we split the demo in 4 parts. First, we are considering variables and why we're switching from the considering variable switching to signals. In this part of the demo, we are switching from regular variables to signals to show how signals make managing data easier. By making this switch, we reduce unnecessary code to improve how the application reacts to changes. Here we have a simple application with simple game. We have some variables with simple methods, and you see what we have done. If we do an increment, the count is list, and we change a message, hello is changed. This is a traditional approach, as they say, out of the box Angular. When using regular variables, changes to these variables does not automatically show in the UI. To make sure the changes appear in the screen, we rely on Angular change detection system. Angular gives us tools like change detection ref or async pipes to help us with that. But these approaches can sometimes make applications slower, especially, let's say, in the larger applications. For example, if you have a variable storing a number or a message, as show you here, updating directly won't show the change on the screen right away, unless Angular runs its change detection. Now you can see we are going to switch to the reactive programming with signals. Now we have hello signals. Signals, I'll show you code again. Signals offer a better way and a more efficient way to handle changes in the data. A signal is like a reactive container that automatically keeps a track of changes. When the value of signal changes, any UI element or service that depends on the signal automatically update. Signals ensure that when the value changes, everything depending on its value updates right away without need to trigger Angular change detection. There are some benefits, of course, switching to the signals. First of all is automatic reactivity. Signal tracks changes and automatically update the UI when the signal value changes, reducing the need for manual checks. We have much cleaner code, as we think. The code for managing and updating data becomes simpler and more organized without the need for complex logic to change detection. And also, most important thing is better performance, especially in large application. Signal can improve performance by making updates more effective and targeted. You will see we'll have switched from the traditional variables to the signals, and we keep the same functionality as it was with the signals. Now we are going to switch to some demo, second part of the demo, and that is how we can use type of signals. We are focusing on computed signals and effects. Here we have again another simple page that will show increment count, but keep in mind this now, something is going to happen that we are going to discuss it in this part of the demo. If we increment the count, you will see we have a count, we have now double account, we say hello, this is variables, we are switching variables, and something is showing the true. If we increment the count is increment with 7, here is we have a double account. As I said, in this demo, this is another component that we created. This is a traditional approach. In this demo, we are going to, as I said, we are going to explore computed signals, also effects, and some common issues with the template. We'll also talk about why not all variables should not be computed signals. First, let me show you how the page works. As I show you, just a simple page. As you see, we have some variables, we have a double count to show then, and also with some new get that will get something from the string of the rows and return true or false in it. We have increment that increase the count and also double count. We also have a change message. Now let's switch to the signals. Check with video. Now you will see we kept the entire functionality again. Say, and we had change message, now hello signals. Here we applied some new types. First of all, signals, we apply subcomputed signal called double account, which is the base of the value of the count signal. Every time count changes, double account is automatically updated. This is great for cases where you have values that depend on other signals and you stay in sync. For example, here we increment the count. The computed double count will automatically reflect the new value without needing for extra logic because it's a computed signal. But in this way, it is important to understand that not all variables has to be a computed signal. Computed signals are useful when the value of one variable depends on another value. However, if a variable is independent and does not need to be recalculated based on another value, it doesn't make sense to use a computed signal. This value is updated directly and does not depend on any other signal or value. Therefore, it can be just a regular signal, not a computed one. This is an example that I show you with this one. This not should be computed signal because it, as said, is optimated just once. It does not depend on the other value. This means that this should be a simple signal that we update at the beginning of our journey to the start component initializing. The value is updated directly and does not depend on other signal or the value. Therefore, it's just a regular signal and not computed one. Using computed signal would be unnecessary complicated things without benefits here. The key takeaway is that computed signal should be used only when there is real dependency. As I mentioned, if a value is static, in this case, or can be changed directly without depending on the other signals, a regular signal is just enough. This keeps the code much cleaner. Also, at the beginning, I show you to have example something happened here, and that is the problem with switching from normal variables to signals. We have some template issues. Template issues. A common mistake with the signal is Angular template. In Angular templates is forgetting to use parentheses. If you forget the parentheses, Angular will still build the template successful, but it will lead to incorrect behavior. Instead of showing the correct value, the UI might display something object to object or other unexpected or something or nothing. This is the example. If you see, we forgot it here to add, even though this doesn't cause a build error, it's important to remember the signal must always be called in functions, like functions in template. Let's save this now. You will see we don't have that count. When you just started, the count is shown. With variables, we don't have that problem, but now with switching to that types, we have to have in mind that that is a common problem with switching from signals to switching from variables to signal. And another powerful thing I want to show you is signal type effect. Here we also implemented an effect that logs the value of the count whatever is changed. You see, this is the example. Effects allow you to run side operations such as logging or making HTTP requests. Wherever the signal changes, they don't modify the signal directly, just react to changes. And effects are really needed in most, not really needed in most applications. Might be useful in specific situation. I will now show you the real world scenario where the effects, basically the signals effects are used for some kind of debugging, but there is a real world example that you can use effect, not just logging the things. Now I will show you the real world example. Here we have some table that have some rows inside. We want, when we click on the table, we are calling endpoint and showing extra data for that row. If we say another one, we also get, we are calling the another one. If it's another row, we are showing the another one. How is that implemented in the code? We have one table row that on click, we are calling some method, and we could go on the method. You will see it just updates the value of the signal. If you get back to the template, you will see we have some component that is receiving that signal as input value. And if you go in the assignment details now here, we'll see we have effect. And we are counting that something we are calling the API whatever we are doing to see if assignment result has changed. This means if we click on this row, the signal will change, new input for this component will get, and the effect will trigger. The effect knows it will call the HTTP request. But there is some also good thing here. If you click on the second one, you will see we call details. If you click on the third one, you will see we call details here. But again, if we click on the third one, nothing happens. This is good, of course, because we don't want to get the data again. We already have the data. It means the signal hasn't been changed and the effect will not trigger it. The effect track the changes of that. This is good real world scenario where you can use the effects. I know you can do it this by Eric.js, but this is also, let's say, sorry. Okay, this is how you can do it, your effect. Okay, now I'm going to switch to another part of the demo, and that is how we implement the input signal and how we increment that. I'll show you just input signals. Those are the inputs. Of course, we have some parent component, they have some value, we have person. I will show the right way what's going on. Now we're going to explore input signals and different way to increment values using both the traditional and signal-based approach. The key here is to see how we can handle input signals, update them, and understand how Signal API can simplify this process. You will see we have one component that has some signal. In HTML, we have another child component. We are transferring it to input, and here we have a simple input that old API, and we have increment person here to it. We are showing the person. You will see the person has name, last name, and age. When you go here, we are going to increment the person age. You will see it will increment the person age, and also in the parent component, we are increasing, showing the data that is mutated in child component. First, we have the standard way of handling input this way, where the simply increment of person age using traditional variables. This method is straightforward to say, but as you see, it doesn't have the activity the signal offers. In this approach, the person age is updated directly in the increment person age as a method. It works, but it lacks the automatic reactivity and simplicity that we got from the signals, of course. What we have done, let's now switch to the signals. This is the new API signal fetching. Now, in this case, we use input required person to create the input signal. However, this challenge when trying to directly update the input signal, here showing the code, here we see a common issues. Trying to update the input signal directly. This will not work properly because Angular Signal API does not allow you to mutate the input signal directly. This is a great point to show where the Signal API has limitation in this context and why we need new alternative approach. You can do it several solutions like here, but I will try to show you two of them. First of all, to work around this, we can do it this way. Commented this and this, and I'll just briefly show you what we have done. I comment this and also get back to this. To work around, we can use a local signal. Let's go back here. Updated person to hold the updated value, which is derived from the input signal. This allows us to properly increment the value while preserving the reactivity of the signals. With this solution, we are able to capture the input signal initial value and then use in local signal updated person here, which keeps the reactivity behavior signal intact. However, you will see every time increment person age call, we updated person. However, as I said, while we have added here the output to help with communication, it doesn't provide a direct way to keep data in sync between child and parent component. When data is sent through an emitting event, the parent component must manually update the child component if the data change. Of course, this can lead to complex data flows and synchronization issues, of course. For example, I will show you we have to do it with imprint if we update that person page. Here in the input component, you will see we have to manually update person age. This was another solution to do it. Now complete here. Sorry, we are switching here to signals. You will see it works, but as I said, with output and creating a new signal. Then we think maybe the good solution is to implement another way. Input signals with the service. This is the second solution we are trying to show. I'll comment at this. This one. Now we don't need anymore this. Show this. This anymore. This solution abstracts the input value into service, allowing for centralized state management. You will see we preserve the same functionality here, but what we have done, especially with dealing with external data or complex state, is using a service is a good thing. In this solution, the value is stored in the domain service. I will show you domain service. Here is another person. And the component retrieves and updates the value from from the domain service. Preferred approach when the data or logic need to be shared across multiple components or services. This avoids directly handing input mutation with the component and delegates that responsibility to the dedicated service. You will see here that we are calling some method in the domain service. We are updating, incrementing person age. We are not directly working on that. We're just referring to that and update it inside the service. The service is responsible for updating, incrementing person age. This is the thing we want to show you about. This is the demo 3 we have shown you, and now I will go to the demo 4, unit testing in the signals. In this next demo, I will show you how to test signals, compute the signals, and effects. We are going to focus on 3 main aspects. First, we have a direct signal. You will see here what we have done. We have count message set here. We also have a double account here. If you can remember what we have done here, we have computed double count message here. So first, we test direct signal. Here I have signed signal count in the type component as I show you. We initialize it and check if the updates directly. For example, if I call increment and expected count to increase. If I call increment, I expected the count to increase by 1 because I'm set it to 0 here. Next, we can test also the computed signal. You'll see I have a double account, which should always be the twice value of the count. By setting a count, I can check here that double accounts reflect these changes correctly. If I call increment, I have set the count to 0. If I increment, the count will be 1, but I expect the double account to be twice of the count. And finally, we have to test the signal. We have actual effects. There are triggered when the signal changes, like logging the message when count updates. This here. Here I have used Pion console to check the effect triggers as expected. You will see if I call increment, the update of the count is increased, and then I check if the console is called. This is a way to ensure that our signal, computer signal, and effects all work as indeed, making our reactivity patterns reliable. And basically, this is a fully demo. We split it in 4 parts. I show you the simple way, switching from the variables to the signals. I show you the types, computer signals and effect, also real world scenario for the effects. We have shown you several inputs, how to manage input state of the signal inside the component. Do you want to derive it to another signal, or you wanted to put it in the, and there is also some, of course, some other way that you can handle that, adding by this, adding some local states, whatever you want to do with that. But this is our approach we are implementing in our application. And finally, I have shown you how you can easily test the signals, how to test effects, how to test computed and simple signal.
Thank you, Miomir. Now, if you'd like to ask some questions.
Thank you, Mimir, for all examples and the things that you showed to us. I think that most of them, just want to clarify for the all attendees, most of these things we find out by transitioning from the Angular 15 or 16 to 17 and 18. We have a code base that is really 7-8 applications that were built from Angular 5 or 6 till this day. So we encounter all of this situation during our transformation to signals. Some of those things we experienced ourselves, and our approach is to go slowly. First, we divided the workload by introducing just signals into components as a first phase, and then second phase was input and outputs because they are much more complex, as Miomir showed to us. There is one question in from Boris. He's asking, would we recommend using signals in a shared service for component communication? My straight answer is yes and no. I think that it can be very useful to have signals in services when you want to remove behavior subject or subjects that you have like event emitters in your services, if you had that. So then signals can be a significant enhancement to the code base that you have. From other point, if you are adding signals into services, then you have to wrap them around in components into another signal so that you preserve the same thing that Miomir showed to us, how to update that signal, how to manage a mutation of the objects and so on. So from one hand, I will say yes. From other hand, I would try to avoid as much as possible. I'm not saying that it is not useful to have signals in services, but I will try to avoid them because from my perspective, services are used for domain logic, for logic that is not always have to be in some way connected directly to the components, but rather wrapped around the components. So other thing where signals, or the other way how signals can be avoided in services, is by using some of solutions that are, or frameworks that are related to state management, like store can be used for this one. And then if you have some kind of a change in your service, you will trigger the change in store, either in a signal store or inside the NX, NG store, sorry. So that is the answer to my question about signals. Does anyone else have some other question related to this? Okay, I don't see any other questions.
Okay.
Okay.
Okay, so thank you all for attending, and we hope you found this session insightful and informative. After the webinar, we will share the recording, the presentation, and also the code that was used in today's demonstration. So please keep an eye on your emails for these updates. We also noticed some of the people coming in a little bit late. So if you have any additional questions, feel free to reach out. We'll be happy to assist you further. And thank you again for your time. We hope to see you at some of our future webinars.
Just a second, we received one more question. It is coming from Angelica. She's asking, because of signals, do you think that RxJS subject of all kind will be deprecated? I don't think so. I think that RxJS will remain a crucial part for Angular in future also. I cannot imagine Angular without RxJS. So I think that every asynchronous communication will still continue to work with RxJS. And it seems like the signals are just extensions. I cannot say extensions, but it is extending the RxJS things and simplify the RxJS things that we saw. I think that signals are mainly created in Angular framework to create a better performance for the rendering, because there was a issue in the, not issue, but performance penalties in the life cycles if you are mutating variables or fields somewhere, and then Angular have to figure out what needs to be updated in HTML, how to replace the certain parts of HTML with the values that are coming from fields or properties or functions and so on. So I think that signals are now offering the way how you can how Angular can easily figure out what needs to be updated. So whatever you've wrapped in the signal, it will become a part of integral part of Angular, and you don't need to detect changes. So I think that is the basic value of signals are better rendering performances. So I don't think that RxJS will be deprecated in any way.
Thank you, Vladimir. Thank you, everyone, again. If there are no questions, we would like to close the session. And as I said before, feel free to email us or reach out on LinkedIn or wherever, so we answer any additional questions that you may have.
Thank you all.
Thank you.
Thank you all.